So today we are going to learn about applied networking. Applied networking. We're going to look at devices to network connection. We're going to learn how to configure devices for wired and wireless networks. We're going to talk about a MAC address, IP addressing. We're going to talk about how to configure NIC for wired and wireless networking. All right. So we are also going to configure wireless networking in a small LAN. Then we'll progress to how to configure firewall settings and IoT devices. So that is what we are going to do. All right. So in order not to waste time, we are moving on straight into the lecture. Going to the lecture so straight. We want to start by talking, we are starting from the network addresses. We have two types of network addresses. When a device is connected to the network, there are two addresses that the network, expects to see from a device. And of necessity, the two addresses must be there. One is called a MAC address. Just like the screen that you are looking at now, you will see that we have a fingerprint, which is unique for every person. Your fingerprint is unique to you. Your fingerprint is not similar to that of any other person in the whole wide world. So we have what we call MAC address, which is actually like fingerprint to networking devices. Every network device has a fingerprint, which is actually the MAC address. Now, when you look at the screen here, you will see the format of MAC address up here. You will see the way the address is presented. It's actually in the form of an alphanumeric combination of digits, which could be arranged with as 22 separated by short dash, or perhaps 22 separated by colon, or arranged in 4-4. So these are alphanumeric characters, numbers, and alphabets that are combined to identify a particular device, and it's unique for any particular device in the whole wide world. Every networking device, be it computer, be it a desktop or laptop, mobile devices such as tabs, tablets, mobile phones, every device that can communicate on the internet, that can be connected to the internet, has a MAC address that is unique to it, that is not mixed up with any other, that cannot mix up with any other device. Now, apart from that, we have also the IP address. IP address is the number which we can call a pass, a gate pass, that is assigned to a device so that it can communicate onto a network, it can enter into a network. That one is just like when you are going to enter into a hall that is locked. You need to get a key. You use the key to open the door so that you can enter into the hall. For a device to communicate on the network, the device must have what we call IP address. IP address is Internet Protocol Address. All right. Now, Internet Protocol Address is what we have here, which is IPv4. The address format of IPv4 is the one we have on top here. IPv4 is Internet Protocol version 4 address format. So we have combination of numbers that are separated by, period, that is full stop. We have 4 group of numbers separated by full stop. Then we have the IPv6. IPv6 comes in alphanumeric hexadecimal formats. Hexadecimal, like the MAC address. MAC address has a hexadecimal mixed with even digital decimal numbers. And in the MAC address, we have hexadecimal, 2 hexadecimal number, 4 hexadecimal numbers separated by periods or colons or hyphens. In the IPv6, we also have hexadecimal numbers that about 128 bits, in size. And then we can have a compressed format of it, which is still 128-bit, but compressed by using special character, special sign to compress some of the parts of the IPv6 address. So that is that about MAC address and then IP address. IP address is issued either manually by someone to his device to communicate to a network, or issued automatically by the network itself to the device. Now, when you connect a laptop to a different network, what you now expect is that the IP address will change, but the MAC address will remain the same. The MAC address stays the same, but the IPv4 and IPv6 address that the device has been using to communicate to the network where it was before will now change to another one. So you could see from this demonstration, you could see this device, laptop here, that has the MAC address on top, 00-50-56-BE-D7-87. It's moved from LAN network 1 to LAN network 2. So when it was moved, you will realize that the MAC address remains the same at the second network, but the IPv4 and IPv6 addresses changed as it moved to another network. And the networks are linked together by a router. Well, they are linked together by a router. All right. Now, MAC address is unique, and that is part of a network interface card. It's a unique number that is part of network interface card. Also, MAC address, MAC address has been issued by manufacturer where the device is, produced. The MAC address has been stored there and it cannot change. It's permanent. But IP address can change from network to network by probably the company can change it by assigning a new one to the device, or internet provider can assign a new number to the device. Now, if you want to know where your IP address or your MAC address are stored in your computer, you can use a command on the computer. Now, the black screen you are seeing on the screen here is called command prompts. Command prompts. Now, we have so many things written on this black screen because a command has been applied to the computer where these screenshots was taken from. Now, if you want to bring out the command prompt, if you are using Windows 20, for instance, you can click on Start and type CMD into the search box and click Enter. So you can now see the command prompt like what you have on my screen now. Now, what you have on my screen is a command prompt that has not, received any command. Now, for you to display the addresses, MAC address and then IP address of a particular computer system that's on the network, we use the command ipconfig/all. ipconfig/all. So from the prompt here, you type ipconfig, okay, in lowercase, ipconfig. In lowercase, not in uppercase, ipconfig/all, then you press enter. Then all the addresses are displayed. If you pay attention to this computer, you see the network address I'm using here, the IP address. Then we also, if you check very well, you see what they wrote somewhere. They wrote physical address. Physical address. Wherever you see physical address, that is the MAC address. This is a physical address, which is a MAC address of this computer system that I'm using right now. This is a physical address. All right. And so even the Ethernet adapter that is inside the system that is making it to communicate with the network has its own physical address, which is another, another MAC address for that device. So, but for the computer itself, we have the physical address, which is a MAC address over here. And then if you check down, you can now see IP address with which is communicating with the network and so on and so forth. All right, so ipconfig/all, we display all the addresses on the computer system. Now, the IPv4 address format, it has two parts. The first part is the network part, and the second one is the host part. Now, like I said earlier, the IPv4 has 4 bands of numbers separated by period. The first 3 sets of the numbers there that are written in 3 digits, they are the network portion of the address, like you see here, that is displayed here. And this network portion is due to the same subnet mask. So they are common, to IP address of computer system that are on the same network. Now, the last part of that number is the host that identify the particular device on the network. If you look at this case now, we have 192.168.200.8. The 192.168.200, those 3 are the network portion of the market of the IP address. And then the 8 is the host. And the host actually indicates the particular device that is connected to the internet, this particular device. So another device can now carry 192.168.200.7.9.10, depending on how many devices you have connected on that same network. Now this IP address number that is written as 192.168.200.8 will be interpreted into 1 and 0 by the computer system internally to form something like what we have here. You now see the numbers written in binary formats, the network portion, and then the host portion. And these are the full, IP address number, which has IP address itself, the subnet mask, and the default gateway. The default gateway is 192.168.200.0. That's the default. Now, it is this default that all other devices communicated, all other computers connected to this network will be issued, and the same subnet mask, but the IP will be changing. The last portion of the IP will be changing to identify different devices. All right. So IPv6 address format. IPv6 address format is an hexadecimal addressing system. That is base 16. And then the rules of addressing is such that we omit zeros, leading zeros, the number. If you want to write it in full, check this screen now. What we have on top here is in full. The IP address version V6, version 6, has been written out completely. But for it to be compressed, some portion of it will be removed and represented by special signs. For instance, if you look at the second line here, we have 000, 000, 000, 000 here, 3 bands of 000 written for 4 zeros written 3 times. And likewise, the last one here, we have 4 bands of 000 written 1, 2, 3, 4, 5, 6 times. So those ones can be compressed by omitting all the zeros there and then using double colons, press colon twice to represent. Now, when you check at the bottom here, you see the compressed version of these numbers that has been compressed. You can now see that 0db8 can be represented as db8, and the one that has 00000 can be represented by double colons. So you can see that here, the 00000 have been eliminated, and then they are represented by double colon in the last one. That is compressed. Now, when there are no leading O's, we have all the 000,440 represented as only 1 0 with a colon. That's how it is. That is the V6 addressing format. Now, we have static addressing. Static addressing means you open your device, the computer or your mobile phone, to type in the numbers, the addressing yourself, whether IPv4 or IPv6. That is static addressing. And so, like I have explained, you must enter the host part of the network part of the IP address and the host part of it, which completely, if you want to do it completely, we have IP address, subnet mask, and default gateway. And that is how IPv4 goes. That is for IPv4. Now, the default gateway is issued to devices so that the information, the system can send information over the network to another network. So the default gateway is the address of the router. It is the router address that carries information from this network to outside networks. And then the DNS server is a part of the system that converts the domain names or URLs into IP addresses, because the system actually reaches these websites or URLs by means of addressing. So the DNS server is the one that converts all the domain names, like for instance, the Cisco.com, the Facebook.com, the Google.com. They will be converted, to their IP address. The device that does that is the DNS server. So the DNS server is the one that does that, and it has its own number too on the network. So that is why you have the DNS server addressing also added to IPv4. Now the same thing goes to IPv6. It has the network portion of the address, the host portion of the address, the default gateway, and the alternate DNS, preferred DNS server, but using hexadecimal, hexadecimal characters to represent all the addresses, rather than using decimal numbers. It uses hexadecimal. Decimal numbers is what IPv4 uses, and then that is numbers that you can read, like 1, 2, 3, and so on. But hexadecimal numbers is a mixture of numerals from 0 to 9 and letters. We move on now to dynamic addressing. Dynamic addressing is when you are connecting a device to the network and you do not want to manually enter the IP addresses so that the device can be communicating with the network. What you choose to do is you open the addressing portion of the system, the network address portion of the system, and you click obtain an IP address automatically. The previous setting, you will click use the following IP address. Use the following IP address. But for dynamic addressing, you click obtain an IP address automatically. When that happens, the device that issues IP address on the server that the system is about to connect to, we send the IP address and save it to the system so that the system can communicate with the network. And that is the DHP server. DHP server is the one that governs the issuance, distribution of IP address to devices. So once the obtain IP address automatically is selected in the system, the DHP server will issue the IP address to the system and save it there so that it can be linked to the network and communicate. Once you click that, then you click OK. So the device will obtain the IP address automatically from the network, either IPv4 or IPv6, whichever one the network is actually distributing. The DHCP server has been configured to distribute with the issue to the system. Now we want to talk about linking local IPv4 and IPv6 addresses. IPv4 devices use information that cannot obtain IPv4 device is used if the device cannot obtain an IPv4 IP address. So, and then apart from that, IPv6 device must always have a dynamic or manually configured link local IPv6 or IP address. So that is how happens. IPv4 device is used when the device cannot obtain an IPv4 IP address. So it has to be configured and the static addressing will be employed. Okay. Now, we want to talk about network design. For a computer system to communicate to the network, there is a hardware responsible for sending signal data to the internet and receiving it back, and that is the network interface card or wireless network interface card, whichever one is being used. So the network component, the hardware component that does that is the NIC, network interface card. All right. For instance, now we have a network here. For the network to be able to communicate to the internet, for the computer in this home to communicate to the internet, the computer is set up in the house. It is linked through a wireless router wirelessly, receiving and sending signal to the router. The router itself is linked to a broadband modem, which communicates with the ISP, the internet service provider, wirelessly also. So in this situation, there are at least 2 devices in the local setting that will communicate with another device, which is from the internet service provider. Now, for small businesses and homes, wireless routers can be used in this manner to ensure access to the internet by means of switches or routers. Now, to select the network interface card depends on what you want to achieve, the method you wish to connect to the internet. To connect through a LAN by means of cables, we use network interface card by which you connect through a LAN cable to your system via the RJ45 ports. Okay. Now, to browse wirelessly, a desktop will require a wireless network interface card to be installed into the adapter card, and then the driver installed also, where the antenna is positioned at the back of the system, and then the system will communicate wirelessly, to the network. Or perhaps you can use a modem like a small dongle provided by internet service providers, and that will be connected to the system via USB ports. Then the internet network will be communicated to the device. When you install NIC or probably wireless NIC, it requires updating the drivers. When you install it, then you must use your device manager to check whether the driver has been installed or not by going to the computer system and then open the device manager. When you open the device manager, then you'll be able to check for driver updates. Go to the device. For instance, on this screen now, we have the network adapters. Under network adapters, we see Broadcom, Nextstream, Gigabit Ethernet. So before this can be displayed, you will click on the network adapters or click twice. Then the adapter that is available that has been installed to the system will display, such as what we have here. Then you can right click on that and then show the details from which you can see driver details. And then if need be, you need to click on update driver. Now, for you to know whether you need to update driver or not, when you open the network adapter and then you see the adapter that has been installed, it will be marked with a sign to show that the driver is not installed, like a yellow sign will be appearing against that device. Any device on the device manager that carries a yellow sign will more often than not require an update of the driver. All right. That is it. So that is how to install it, because ordinarily if you install the adapter card, it will not ordinarily communicate unless the driver has been installed. The drivers are the software that will connect the device up to the operating system and make it work the way it should. Now, to configure a network interface card manually for mobile devices, one has to open the mobile device internet network page like we have on the screen here. The device must also receive network IP addresses, otherwise it will not be able to communicate with any network. So sometimes you may require to do this manually. Your device may not receive the addresses automatically from the network. So then you will open the portion of the wireless portion on the device and go to configure IP. Then you can, if you choose automatic, then all the IP addresses, the numbers will be stored automatically to the device. Else, you can type them in and save. You can type them in manually. If you choose manual setting, then you must have obtained the IP address numbers, which is IP address, subnet mask, the router. You must have obtained it from the network interface, service provider. Type them in, then click on save. With that, the device will be able to communicate with the network. Then we also have ICMP. ICMP is a command. It's a set of commands, and then one of them that we may require to test whether a device is actually communicating with the network is the ping command. We carry that out also from the command prompts, like we used earlier, command prompts. So I've cleared the screen by typing CLS and then pressing enter. So here we can type the command ping. Then when you type the command ping, then it will be followed by the website that you want to actually reach or the IP address that you want to reach. Then you press enter. So what you do in this instance is that you send the system to move through the destination that you typed, whether it can go there and reach that destination or not. So that ping command is part of ICMP, that is Internet Control Message Protocol, that is used to, to check, if your device can communicate on your network. And then it returns. When it returns, it brings back details of what happens during the check. You see ping statistics, for instance, on this screen for this IP address, which can actually be a particular domain name, which is a website. The packet sent, packet received, packets lost, percentage lost. You will see it. Then the round trip time to go and come back, to go to that destination and return, it tells you in seconds here or milliseconds. Then for a successful, trip, you will see that the packet sent will be equal to packet received, and there will be no lost packets. And that is how to know that the device is actually communicating on the network. It can go and come back on the network. So that is the command that we use to check that. So we've learned a great deal today. Another time we are going to continue, okay, today we also look at linking wire devices to the internet to connect a simple system like a standalone desktop or laptop to the network using cables. So for instance, we can follow these 3 steps. One is to connect the cable to the device. That is the LAN cable, the local area network cable, which we are using to communicate with the network. Then the other end of the cable will be connected to a switch, that is internet switch. And that will be the yellow port here from the computer system to the yellow port. And then from the switch, we have to connect to the modem, that is the modem that is serving, that is bringing the network service. So we use the blue port. You connect the cable between the wireless router from the blue ports on the switch there to the broadband modem. With that, we'll be able to set up a network system for that standalone computer to be able to communicate to the internet. The broadband modem actually communicates wirelessly with the ISP, the internet service provider, and that is it. Okay, so in another discussion that we're going to have in the future, we discuss about how to set up a router in the network. So here is where we are going to stop for the lecture today. Thank you very much for listening. I want you to watch it over and over and then make comments, ask questions in the comment at the comment section that I will respond to. Thank you very much.